Again, here with another question from topic 7.2. This is an IB question bank question on nuclear reactions. We have a nucleus of radium, which is isotope 226, undergoes alpha particle decay to form a nucleus of radon. We want to identify the proton number and the nucleon number of the nucleus. Well, the number 226 gives us the clue that we need to start. And 91 gives us the rest. So that's this 91 here. 91 is telling us that radium is made of 91 protons, and 226 tells us that it's made of 226 nucleons in general. That's what we start with, 226 nucleons, 91 of which are protons. An alpha particle comes out of that, and an alpha particle is 2 protons, 2 neutrons, in a single nucleus. So if 2 protons are removed from the existing 91, that leaves 89. Protons and neutrons both count as nucleons, so if we start with 226 and remove 4 of them, that leaves 222. Immediately after decay of a stadium-radium nucleus, the alpha particle and the radon nucleus move off in opposite directions at different speeds. So we started with a stationary radium nucleus. It's split into radon and the alpha particle. They went off in opposite directions and different speeds. We want to outline the reasons why this might have happened. All right. What we have here is an explosion. A source of energy, the nuclear potential energy, is released, and it's transformed into many things, including primarily the kinetic energy of the 2 particles. And we know from topic 2 that in collisions and explosions, momentum is always conserved. So we have conservation of momentum. Which means that they must be moving at different speeds because they have different masses. And they must be moving in opposite directions because there was no initial momentum. So because we start at a stationary radium nucleus with no initial momentum, when one starts moving, the other must move in the opposite direction due to conservation of momentum. And they must move at different speeds because they have different masses, but contain the same amount of momentum each. Outline why a beta particle has a longer range in air than an alpha particle of the same energy. Well, beta particles have less mass than an alpha particle, which means that the beta particle moves faster. The beta particle also has less charge than an alpha particle. It also has less mass than an alpha particle. So it will interact with other things like the air less frequently. Less charge, less mass, less frequent interactions. At the same time, it's moving through the material faster, so it has fewer opportunities to get pulled in to other objects as it barrels through the air.